Well, it's really good to see all of you. Lots of familiar faces, some new faces. Yeah, as John said, I've been at Berkeley for the past 5 years, but I want to talk to you today about something new that I'm doing. So I went on leave about a month ago to start a new nonprofit AI lab. So I guess first of all, who are we? So we're a nonprofit AI lab building open, scalable technology to help address emerging challenges, risks, and policy questions from AI. There's two co-founders right now, me and my co-founder Sarah Schwetman, who was previously a research scientist at MIT and has founded a couple other nonprofits. And we want, our kind of mission is we feel like right now, AI is mostly being developed behind closed doors by for-profit companies. That's to be expected. But there needs to also be someone representing the public interest and ensuring that these really powerful systems that are being built are actually kind of aligned with the public interest. So we have about $5 million in funding so far. We're looking to raise more than that. My goal for the end of the year is $30 million. We have a couple advisors, Joshua Benjo and Percy Liang. But we're at Hertz, so I want to kind of tell you about the tech rather than kind of the other stuff. So what are we kind of trying to do? So we're trying to build tools that will allow us to deeply understand and steer the behavior of a frontier AI system. Right now, we're focused on language models like ChatGPT or Claude. And so how does this kind of work? Do I have a laser pointer? I do, great, okay. How does this kind of work? There's some AI model we want to understand. We're going to train a lot of other AI models. These are generally going to be smaller models that we call investigator agents to basically kind of query and understand this model in lots of different ways and build up a database of information about that model. What are all of the kind of concepts that that model represents inside of it and how are they used? What are the different behaviors that can be elicited? And once you have this database, this can kind of power lots of different tools. You could imagine kind of interpretability overlays where maybe I ask a language model a question, it gives me some advice, but it's probably making a lot of implicit inferences about me when it's giving that advice. If I ask, what should I wear to this event? It's probably making assumptions about my age, what sort of event it is, my gender, and could we actually just see what those are by kind of querying this concept database and even steer them? What different advice would it have given me if it believes something different about me? So that's just an example. There's a lot of things you could do once you had this. What are some examples of what this might look like? So this is something that Sarah built while she was still at MIT. You could have some kind of vision model that is that kind of has a bunch of different neurons that that classify images in different ways, and you could kind of give some AI system a bunch of tools, ways to query data, ways to kind of make new images given text, edit images, all of these things. Give it a memory so it can log experiments, and then kind of just ask it questions and have it run for a while. So you might say, okay, what is neuron 355 in this model doing? And it might do a bunch of things, including kind of creating and editing some images, and then it concludes that this neuron responds to Spider-Man imagery. So this is, and then this would kind of go into the concept database. And so here we have this agent that's kind of a description agent that's describing concepts. You could also have agents that are trying to answer questions about behavior. Are biases present in some class, and it kind of generates different images and concludes that it's biased towards cases where this image appears in a fishing context. A tench is a type of fish. And so this is what we'd be calling an auditing agent because it's kind of trying to audit the behavior. We've done this in other cases as well. So this is something I've worked on where there's this model called CLIP that's kind of joint text image model. And so you can kind of look at its neurons, look at their effects in the model. For the text neurons, you can kind of decompose them into a bunch of different text concepts. And you can use this to actually find problems in the model. So it turns out there's a single neuron that cares about dogs, elephants, the sun, the concept of value. And so if you create an image where you say a cat lounging in the sun with a group of elephants in the background and a value sign in the foreground, you get this nice image, and it thinks that it's a dog and not a cat. And this is very reproducible. Oops, I lost. OK, here, this is still working. So here you see there's kind of different agents, right? There's this description agent, this auditing agent, and we have these concepts and behaviors again. This is very reproducible. So this is like a stop sign that's misclassified as a yield sign, a cat that's misclassified as a vacuum cleaner, a dog that's misclassified as a deer. And there, we have other systems we've been building that can find all sorts of failures. Like it says this is an empty glass. This is a family of 5 members, even though there's 6, and so on. So this is really cool. What's next for us? So we want to scale this machinery up, starting with this concept database. These models were about maybe 500 million parameters and had somewhat simple architectures. We're now trying to scale this up to Llama 3 8 billion, so that's 16 times larger, has a more complex architecture, and trying to answer questions like what inputs activate each feature or neuron in the model, and what are these used for. So this is just a very preliminary example. Sorry that the text is kind of small. This is neuron number 3 out of 14,000. These are kind of some of the things that positively activate the neuron. These are some of the things that negatively activate it. If you could read this, you would see it talks about things like cash flow, earning growth, dollars, revenue. And so then we have these automatically generated descriptions from these kind of describer agents that say, OK, this actually responds to things like financial and business terms, and so on. And then we actually have ways of scoring this as well, right? So this is a scientific hypothesis. You could test it. You could actually think of this as doing kind of automated neuroscience on these models. If we believe that that's actually what this neuron does, then we should be able to predict held out behavior. And so this is kind of an example of that. What else do I want to say, since I'm probably at my 10 minutes? You can also look at not just what do these neurons respond to, but what do they write to. This is a bit more complicated because they write to different things in different contexts, and also because there's often like long-term or, well, sort of episodic memory in these models where if it sees something at one point in time, that will affect its prediction at future points in time, and so you need to actually be able to kind of trace those causal paths. So we have some ways of doing this. If you do this for that same neuron that responds to financial terms, it turns out that one of the main things this does is it causes the model, this is a language model, so it causes the model to be more likely to say the word assets or related terms. This experiment was totally independent of the other experiments, so it's kind of a nice sanity check that this stuff all makes sense. What are we doing next? Using this concept dictionary to design better model evaluations. So you could try to look for things like gender bias by looking at, okay, what things are associated with like the words he and she in the model. You could also try to look up other kind of interesting concepts you might care about, like say code vulnerabilities. And we're also trying to kind of improve these concept dictionaries using fine tuning and other methods. If you're interested in staying up to date with us, we have a newsletter. If you want to ask me questions or work for us, or you're a funder and you want to give us money, you can either just talk to me, but if you don't want to talk to me, you can email this. OK, thanks. I will take any questions.
Okay, we have time for 1 or 2 brief questions if we have it.
You have one over here.
Yeah, so you were saying that we need to build something that is more beholden to the public. Mm-hmm. What are your funding sources in particular? Because generally, who funds you is who you end up being beholden to. So if they're like private venture capital, you probably can't hold on to this public model for that long.
Yep. So currently, we're actually funded by just a bunch of different individuals who are excited about this mission, as well as we do have $200K from the Schmidt Foundation. Hopefully, we'll have more from them at some point. But our goal is to have a pretty diverse set of funders. We're continuing to talk to individuals, talking to places like the Omidyar network. I think we will take, some of these individuals are in the VC world, but I think we're going to have a pretty diverse set of sources. But yeah, I think that's a great question.
Another quick question? Going once? I'd like to thank Jacob for being our, oh, we have one.
So are there any applications to your work to understand adversarial AI?
Yeah, so the question was, are there applications of this work to understanding adversarial AI? Yes, so one of the things we have been doing with this is you can kind of use this concept dictionary to kind of automatically generate adversarial examples, because you can kind of find places where these concepts are misrepresented, or there's like a mismatch between what it reads and what it writes. And so I think that's the main connection, yeah.
I think NIST just came out with some kind of evaluation tool for LLMs. How is what you're doing different and better?
Yeah, so NIST is mostly looking at things black box, I believe, although they're starting to kind of do things that are opening up the hood. I would say that what we're trying to create is kind of general purpose tools that could fuel lots of different evaluations, as opposed to things that also are not evaluations, like this idea of kind of an interpretability overlay that would kind of help you to understand what a model is doing on a given input. So, I mean, we've been talking to folks at NIST. I'm definitely excited by what they're doing. I think they're kind of like one layer, we're kind of like adjacent layers in the ecosystem, if that kind of makes sense.
So last question for the moment, but Jacob will be around.
Thank you. Oh no, all right.
Do you think your research could shed any light on the ability of neural nets to actually generalize and deal with things that are out of distribution?
It's a good question. I think in some ways, yes, because it's giving you a way to kind of, look at the concepts and read how it's representing things. And if those representations seem fairly robust, that can help. I think a thing it definitely can do is it can help you to predict kind of long tail or out of distribution failures, right? Because if I kind of look at these representations and they kind of don't make sense, that's like definitely a problem. Or also kind of, not everything is looking at representations. We also have like that kind of thing with the Tench class that I was showing you. So you can also kind of have these auditing agents that will generate out of distribution examples to try to understand what's going on.